We, the students of NMIMIT Newton, having been selected for Texas Instruments Innovation Challenge Analog Design Contest 2014, are here for the video demonstration of our project entitled Electronically Controlled Flexible Suspension for Vehicles to Overcome Jerks Due to Potholes under the guidance of Dr. M.K. Parashuram. The main aim of our project is to detect the potholes and vary the level of suspension accordingly in order to maintain the ride height constant and to provide comfort to the automobile user.
How we achieved this. This is the basic block diagram that describes our project. The camera mounted on the front panel of the vehicle will capture the images continuously. These images are processed in MATLAB to give the distance and position of the pothole from the vehicle. This data is then sent to the microcontroller which controls the suspension system. This is the MSP430 launchpad provided by Texas. An additional velocity sensor is used to calculate the speed of the vehicle. This is also interfaced with the microcontroller to determine the time delay for the release of suspension once the potholes are detected. Designed for a velocity sensor. As you can see, this is the 555 timer and this is OPA227P op-amp provided by Texas Instruments, which acts like a unit gain buffer. To implement velocity sensor, 555 timer is used. It is operated as an astable multivibrator whose output are pulses of variable frequency. To achieve this variable frequency, we are using a 10 kilo ohm potentiometer. The varying frequency represents the varying speed. The output of the velocity sensor is fed to microcontroller, which counts the number of pulses. When the frequency is high, it means the number of pulses are more and hence the vehicle is moving at a higher speed. The reverse is also true.
Algorithm of image processing using MATLAB. This is a code for image processing using MATLAB. Now let us see how it works. We have already captured some images of the potholes and are using them for this demonstration. If the road does not contain any pothole and only the lanes, it detects the lanes and removes it from the image. Initially, the true color image is scanned and if any lanes are detected, it is displayed in the grayscale image where the lanes are removed and it is replaced by the background color, that is the color of the road. This makes the pothole detection easier. Further, it tries to identify the potholes by using some thresholding techniques to identify the sharp contrast area, which is one of the characteristics of the pothole. Now, as you can see in this image, the blue color box represents the pothole and the red color block represents the lane. If the potholes are detected, it is displayed in a binary image. We also have the images of potholes filled with water. Our algorithm is efficient in detecting these potholes also. The code is capable of differentiating between the clean road, the road filled with potholes, and the muddy road. In case if the road is muddy, the pothole detection algorithm is not applied and hence the level of suspension does not change. The data from the MATLAB regarding the position of the potholes is sent serially to the microcontroller. Then the microcontroller is used to interface the velocity sensor. Once the pothole is detected, it measures the speed of the vehicle. This is achieved by continuously monitoring the output of the velocity sensor. The code written for the microcontroller counts the number of pulses and calculates the speed. Then the time delay required to activate the suspension is calculated based on the speed of the vehicle and distance of the pothole from the vehicle. The LED is used as a suspension indicator which turns on after the calculated time delay. The setup is as follows. The image to be processed contains potholes filled with water. It is detected and this LED turns on after some time delay to indicate that the suspension is activated. The next image to be processed contains lanes and potholes. Let us see how the entire setup works. As the LED did not glow, let me tell you the reason behind it. The image is basically cropped into three sections, left, right and the center part. The center part is not subjected to any processing since it is assumed to come in between the left and right sides of the vehicle and tire will not run over it, and hence the suspension is not activated.
Now we'll look into the working of the suspension system. We have two designs here. This is design 1. As you can see, we have two syringes. Handle of one syringe is connected to the handle of other. The body of the two syringes are also connected. The body of one syringe is connected to the tire of the vehicle. Each syringe is connected to a pair of solenoid valves and a tank. When the vehicle encounters a pothole, the tire goes down, pulling the body of the syringe it is attached to. Since the handle is fixed to the base of the vehicle, it rises a little. Due to this, the handle of the other syringe will be pushed up, forcing the liquid inside it to flow out through the solenoid valve. This will be temporarily stored in the tank. Similar but reverse action takes place when it comes out of the pothole. This is our second design for the implementation of suspension system. We have a closed cylinder connected to the tire of the vehicle, a piston connected to the base of the vehicle and some liquid inside. This is connected to a pair of solenoid valves through a two-way hydraulic pump. The suspension length is varied depending on the flow of liquid from upwards or downwards. In both the cases, the solenoid valve is controlled using the microcontroller. A solenoid valve is used to control the suspension. This will help in interfacing the microcontroller and the mechanical system involved in the suspension. For the wiring of solenoid, a circuit with a relay is used. The output from the microcontroller is fed to the relay of the circuit. Of our video demonstration here. Due to lack of time and unavailability of some components, we couldn't complete the implementation entirely. We thank one and all for helping us bring up to the stage. Thank you.